Hi guys, welcome back. It's Nick here and we're working on our transportation game in Unity 5. Where we left off last time, we'd just done some terrain modifications, so we'd created this rather beautiful monstrosity that you see on the screen. I think the reason for that is we're actually modifying the terrain by way too much. So before we do anything else, I'm just going to jump straight back into our terrain manager script and come down to where it says raise terrain and change this to like 0.001. I'm going to add F for float. Also down here I need to change this amount to a float just so it can take that decimal point number. Hopefully it should work a bit nicer now. I'll just play it in C. So I'll find an area that isn't completely destroyed yet. There we go, so now you can see the train is raising much slower, which is a bit more like what we want. I mean, there's a slight flaw in the system because as you raise the terrain it may lead your mouse to click on a different point of terrain, which isn't really what we want, but for now I think it works. But you might notice if I go up to the stats, if you keep your eye on the frames per second count, I just find that. Oh yes, there it is. So I'll switch the time back to 0 so we can see what we're doing, or 10 so it's at least daylight. I don't know what's going on with this. There we go. So we have some sunlight. If you see, we're on about 170 frames per second, maybe 200, because it's a very, very simple game at the moment. But if I start raising the train, watch how that frame rate drops to 8 or 9 frames per second. And there's a reason for that. It's because when we are modifying our terrain, you see we update the entire height system. And there are a lot of points in here. If we, I'm just going to put a debug log so we actually can see, or in fact, even better, I will make these resolution variables public. And we can actually see how many samples we're dealing with here and what kind of update means. So I just replay, go to Terrain Manager. So you see 513 samples in each direction, which is a lot. So you're basically looking at 513 squared. If I bring up calculator, so 513 times 513, yeah, that's 263,000 different numbers we're updating, and we're only actually changing one of them. So it doesn't quite make sense to be doing that. So we're going to look at a different way of doing this. Instead of updating all of the heights, we're just going to update one of them. So for that, I'm going to create a new height object to store the one change we're making. So we're going to do float, two-dimensional float array. That's what the square brackets and comma means. So square bracket means array and the comma means two-dimensional, if you haven't come across that before. And then call that height change. I'm going to make that equal to a new float, and it's just going to be one by one because we're only changing one thing. And I'm just going to say height change at 0, 0, so the only thing is going to be equal to cur height, so the change we're making. And now instead of updating all the heights, all we need to do is update with the height change and the offset. So in this case we want terrain pos y and terrain pos x, and that should give us the correct place. We may have to swap these, I'm not quite sure how this method works, but let's give this a go and see if this works correctly. So let's find a clean bit of land, and there we go. So you see we're now running at a steady 30 frames per second. So it still dips quite dramatically, but we are making changes to a terrain which is usually very efficient, so there's quite a lot going on when we make terrain changes. So I'm very pleased with the way this is going. However, there is a few problems. So the first of which is when you click you change one point, and that's really impractical. What we want to mimic is the brush system that Unity uses in the editor. So when you click raise terrain, you raise a whole area of terrain by a certain amount. So if I click here, I can make small changes like this. So what we want to do is sort of add a sphere of terrain that's modified. So let's jump back into our script. And the other thing I'm not happy with is this method name. The amount essentially can be made negative to make it a lower terrain function. So I'm actually just going to rename this by right-clicking, going refractor, rename. What this will do is this will make sure everywhere this method is used in the script, the Visual Studio will update the name so there's no errors. I'm going to change it to modify terrain and say apply changes. There we go. And along with float amount, I'm going to add an int called radius. Now for now, I'm just going to set it as 1. So essentially this should do the exact same thing as it did before. Then we're going to modify this so we can give this method the radius of a circle, and that's the area that it will affect. So if it's a 1 by 1 circle, it's just going to be 1 square. But as it gets bigger and bigger, obviously it changes. So to start with, we need to change these ones to radius by radius. In fact, I've made a mistake there. They need to be radius times 2 times radius times 2. And we'll be able to see the effect here. In fact, I'm going to boot up Microsoft Excel, and we're going to take a look at the actual effect this radius is going to have. Okay, so I've opened up a new workbook. So say for example you think of each cell in Excel as a sample. So say you click here, the height here is going to be 5, and we've increased it to 5, but the radius is around it is 3. So all of these squares then become affected, except they'll be affected by lesser amounts. So this might be 3. The ones right next to it, and the ones that are still within the radius but aren't quite next to it, maybe they're 2. So you almost have a sphere of influence going on. So if we have radius, I realise radius is probably the wrong word to use. We probably use diameter. Say your diameter of the circle is 3, then we'll have a 3 by 3 grid here. Let me just rename that variable to diameter. Apply those changes. Now we can remove this times 2 here. To start with, instead of just doing that fall off, the reducing in the effect it has the further it is from the centre of the circle, I'm going to start by affecting the whole circle the same amount. And the way I'm going to do this is just doing a for loop. So for int x equals 0, x is less than diameter, x plus plus. And then inside that I'm going to nest another for loop, int y equals 0, sorry, and y is less than diameter, y plus plus, and we're going to modify the height change. So let me just grab this code. It's the height change at, the height change at x comma y should be equal to the heights at terrain pos x, terrain pos y, plus amount. Now I realise terrain pos x and terrain pos y are actually the wrong things here. What we need to do is modify terrain pos x and terrain pos y by the amount of x and y. So I'm actually going to create new variables. So int x2. x2 is going to represent where the x position is relative to the centre of the circle. So if it's here, it's going to be -1. If it's here, it's going to be 0. If it's here, it's going to be 1. And the way we're going to do that is we're going to take the x value, so here it's 0, here it's 1, here it's 2, and we're going to subtract the rounded down version of half the diameter, so 3 rounded down, well 3 halved and rounded down is 1. So essentially we're just subtracting 1 from each of these, and as you can see from these two rows, that works out perfectly. So x2 is equal to x minus, we used int to round down this, x divided by 2. Sorry, diameter divided by 2. And we're going to do the same with y. So we have these two new variables, and what we want to do is do train plus y plus y2, train plus x plus x2. There you go, so we now have the train plus x, train plus y. And the last thing we want to do is modify the set heights function, otherwise it's going to set the height at the wrong position because the offset is still at the original place. So we actually want to do this math again. So we want to subtract from this the diameter divided by 2, so that it starts at the corner of the circle and not at the centre. Now I'm not sure if this is going to work correctly, there is quite a lot of untested code here, but we're going to give it a go. Just to test it, I'm going to change the diameter to 3. So this should affect a few points around the area. We might get an error. Okay, so it seems to be working. Hang on a minute, we've got some strange stuff going on. Oh no, that's just the shadow growing, it's not the actual terrain. Actually, it seems to be only increasing 1 point at the moment. Let's try increasing that radius to, oh, the diameter, sorry, to 20. And double check that this is actually having an effect. 3 might have been just too small to see. Ah, there you go. So we are having an effect. But as you can see, the effect isn't exactly correct. You see here it's modifying the terrain in a sort of backwards way. So I think we have our indexes swapped around when we resave the terrain. Because you see here in this hill, where the terrain's supposed to be high, it's actually going low, and where it's supposed to be low, it's going high. So just check to see if that is the case here. So, oh yeah, we've got x, y, we should probably have that as y, x. Let's just flip back into Unity and see if that's the problem. Yeah, that seemed to be the case. We are modifying a large group of the heights now. It's still not behaving perfectly, but this is something I think we should investigate next time, because we are running a bit long on time. So for now we've added a few efficiency fixes, and we're adding spherical fall off. So this has actually done quite a lot of progress. Next time we're going to finalise this sphere problem, and we'll start looking at some other ways we can modify this terrain. So thank you very much for watching. I've been Pearson, and I'll see you in the next video.